In this video, we're going to prove the following fact. The only prime number for which 3p plus 1 is a perfect square is 5. If you like seeing proofs like this, subscribe to my channel. That's all we do here. Okay, so let's get into the proof. Now what I'm going to write is not part of the proof. I just want you to see what's going on. They're saying p is 5. That is a prime in this form. Only when p is 5, ooh, it's a perfect square. Yeah. A number in this form with p is prime will only be a perfect square when p is 5. Well, let's prove that. Okay, so this means that 3p plus 1 is equal to k squared for some value of k. So k is an integer. So k is of the form 3m plus 1 or 3m plus 2 by the division algorithm. Every integer is either a multiple of 3 or one more than a multiple of 3 or two more than a multiple of 3. Now, if k is equal to 3m, that implies that k squared is 9m squared. And we want 3p plus 1 to equal to 9m squared, which is the same as 3 times 3m squared. Well, this implies that 3 divides 9m squared, which implies that 3 divides this, because it equals 9m squared. But that's not true whether p is a prime number or not. 3 clearly goes into 3p, goes into it p times. The only way p is going to go into the sum is if 3 divides 1, and it doesn't. So k cannot be of the form 3m. This number cannot be on the 3 times table. Well, what if k is of the form 3m plus 1? That implies that k squared will be 3m plus 1 all squared, which is 9m squared plus 6m plus 1, which is 3 times 3m squared plus 2m plus 1. And we want k squared to equal to 3p plus 1. That's where p has to be. So p is equal to that number, 3m squared plus 2m. But this is m times 3m plus 2. So p is a product of those two numbers, but p is prime. So that means m is 1 or 3m plus 2 is 1. Let's take both cases one by one. If m is 1, that implies that k is 3 times 1 plus 1, which is 4, which implies k squared is 16. So we want 3p plus 1 to equal k squared. So that must be 15, because we all know 15 plus 1 is 16. So if 3p is 15, that implies that p is 5, which we know is correct. I mean, I actually tested that. But you don't have to. This theory shows it. Okay, now, what if 3m plus 2 was 1? If 3m plus 2 is 1, that would imply m is negative a third, which isn't necessarily bad that it's a fraction. So k is 3 times m plus 1. Well, that's negative 1 plus 1, which is 0. Well, that implies that, so k is 0. That implies k squared is 0. So we want 3 plus 1 to be k squared. Well, that implies that p is negative a third. Well, a prime number isn't negative a third. So far, all we found is that p can be 5. Okay, what about the last possibility? K is of the form 3m plus 2. Well, that would imply that k squared is 3m plus 2 squared, which is 9m squared plus 12m plus 4. 2 squared is 4, but I'm going to write that as 3 plus 1. Even, in fact, bracket off what I just did. I can pull out a 3 from this, and I'll have 3m squared plus 4m plus 1 plus 1. Okay, well, I want 3p plus 1 to equal k squared, which is 3 times a number plus 1. So p must be 3m squared plus 4m plus 1. So p is 3m squared plus 4m plus 1, but that fact is to 3m plus 1 times m plus 1. So p is a product of 2 integers. That implies that one of the integers must be 1. I almost said one or both of the integers is 1. Well, if they're both 1, 1 times 1 is 1, and p can't equal 1, because 1 is not a prime number. So it's not the mathematical art. So this here tells you that 3m is 0, because 0 plus 1 is 0, so m is 0. We'll accept any possible choice for m. Not going to discriminate. But m is 0. Well, that means k is 3m plus 2, which is 2, which implies k squared is 4. Okay? So we want 3p plus 1 to equal k squared. That means that's 3. 3 plus 1 is 4. So 3p is 1. Ooh, that implies p is a fraction. Can't be. So let's come to this one. m plus 1 is 1. m plus 1 is at 1. That implies that m is 0. Okay, but k is 3 times m plus 2, which is 2. At k equals 2, that implies that k squared is 4. We want 3p plus 1 to be 4. That means that's 3. And if 3p is 3, that means p is 1. But p is an integer. It can't be 1. That completes the video. That completes the proof. The only answer we got was p equals 5. Hence, the only solution really is p is equal to 5. Okay, if p is equal to 5, and only if p is equal to 5, then 3p plus 1 is a perfect square. If you like videos like this where all we do is prove facts, in my opinion, it's a no-brainer. Subscribe to our channel. See you guys in the next video. Don't forget, continue to watch and learn.